Hello everyone, and welcome back to the channel. Within the realm of modern engineering marvels, fighter jets stands as a testament to human ingenuity and technological prowess. The F-15 Eagle, an all-weather multi-role tactical fighter jet, was designed to combat a variety of adversaries. The United States Air Force claims that the aircraft has unprecedented maneuverability and acceleration, as well as a wide range of weapons and advanced avionics that allow them to establish and maintain air superiority on the battlefield. These powerful aircraft have played a significant role in modern aviation and continue to push the boundaries of engineering with their powerful engines. Upon landing, the maintenance of aircraft is a crucial task that ensures the safe and efficient operation of jets. This work requires precision and expertise to keep the aircraft soaring. Airmen, including those within the 48th Fighter Wing, carry out maintenance on the F-15 aircraft. This includes routine maintenance, repairs, and inspections. The 48th Fighter Wing's maintenance group is responsible for performing tasks such as engine overhauls, component replacements, and system checks on the F-15 aircraft. When it comes to repairing the engine, it must first be carefully extracted from the aircraft. The F-15E Strike Eagle is powered by two Pratt & Whitney F-100 PW 220 or 229 engines, which incorporate advanced technology to enhance performance. After successfully removing the engine, the maintenance team follows a specific process. This includes washing and drying the jet engine parts, conducting visual inspections of the exterior and interior, and dismantling the engine. The maintenance team will often start off by inspecting the engine for leaks to ensure that all systems, such as the fuel, cooling, and oil systems, are leak-free. This is done to verify the proper functioning of the engine. The engines are also carefully checked to detect any signs of developing fatigue cracks in the rotors of the jet engines. These cracks could result in low compression or, in the worst case, catastrophic failure. Now that the engine inspections have been completed, it is time to start the engine. When the engines are turned on, fire is shot out from the end as if the aircraft is actually taking off. This process involves evaluating the fuel burn rate and assessing the aircraft's performance in zero-G or severely icy conditions. Although all engines are the same, they may experience different mechanical issues. Therefore, the 4th Component Maintenance Squadron is responsible for actively troubleshooting and diagnosing any problems before reinstalling the engine on the plane. The most common troubleshooting involves monitoring exhaust gas temperatures, analyzing fuel flow, and using instrumentation to assess combustion stability. These maintenance tests are mainly conducted in an enclosed place known as a hush house, which is a noise-suppressed facility and is primarily used for testing aircraft systems, particularly propulsion. The hush houses also include areas for a variety of testing, such as mechanics, electronics, and pneumatics. Additionally, the hush house can accommodate both installed and uninstalled jet engines, allowing them to be tested under real load conditions. The maintenance team conducts several engine run tests to ensure that the engine is capable of producing the required thrust. These run-ups ensure that all aircraft systems are functioning properly before the aircraft takes off. Once the jet is officially flight-ready, the engines are installed on the aircraft and it may take off using full afterburner. The jet afterburner is a crucial component used in certain jet engines, particularly those found on military supersonic aircraft. Its primary function is to enhance thrust, typically for supersonic flight, takeoff, and combat situations. The afterburner increases the thrust of the aircraft by ejecting fuel directly into the exhaust stream and burning it. This remaining oxygen from the initial combustion process ignites and expands the exhaust gases further and can increase the thrust of a jet engine by 50% or more. The F-15 Eagle is capable of producing a maximum thrust of 23,000 to 29,000 pounds, propelling the aircraft to speeds of over twice the speed of sound. Different classes and types of aircraft require different types of maintenance, including line maintenance, heavy maintenance, and shop or component maintenance. Line maintenance involves routine checks and repairs that are performed on a daily basis, while heavy maintenance refers to more extensive repairs and overhauls that are done periodically. Another type of aircraft in the U.S. Air Force fleet is the F-16, a multi-role fighter jet known for its exceptional agility and performance. The F-16 is a single-seat, single-engine aircraft designed for all-weather operations. It boasts superior maneuverability and is equipped with sophisticated tracking and weapon systems, making it ideal for intercepting and attacking other aircraft. Just like the F-15, the F-16 also requires constant maintenance and repairs. Most maintenance on the F-16 can be performed with the engine installed in the jet, but for major engine repairs or replacements, the entire engine must be removed. The F-16 is equipped with a single Pratt & Whitney F-100 PW229 engine, capable of producing a maximum thrust of 29,100 pounds. The aircraft is highly maneuverable and has proven its capabilities in both air-to-air combat and air-to-surface attack. The F-16 is often praised by pilots for its ease of flying and exceptional aerial combat capabilities. Additionally, its timely maintenance ensures that the aircraft is always operational and able to perform its tasks effectively, even in emergency situations. The GE F-110 engine, which powers the F-16 aircraft, has a weight of approximately 2,500 pounds. Here, the maintenance team is removing the aircraft engine for thorough maintenance, necessary repairs, or detailed troubleshooting before sending it back to the plane. Once the aircraft is ready for flight, the pilot takes a test flight to analyze the overall performance of the jet engine. The F-16 is capable of producing a maximum thrust of 23,000 to 29,000 pounds and has a maximum speed of 1,345 miles. In the world of fighter jets and high-performance aircraft, the maintenance of jet engines requires precision technology and unwavering dedication. From removing the powerful jet engines to meticulously maintaining and reassembling the aircraft, every process ensures that the aircraft continues to soar in the sky and is prepared for any future challenges. That's the end of this video. I hope you enjoyed it. Don't forget to subscribe to this channel so you won't miss any of our new content. Until then, take care and see you next time.